Good morning to all. In the last class I taught you about one of the most important problem in the balancing of reciprocating mass, right? In this class I am going to teach you about one of the most important problem in the twin Vee engine. Okay, right? It is a problem. A V engine has the cylinder axis at right angles and the connecting rods operate a common crank. The reciprocating mass per cylinder is 11.5 kg and the crank radius is 75 mm. The length of the connecting rod is 0.3 meter, so that the engine may be balanced for primary forces by means of a revolving balanced mass. If the engine speed is 500 rpm, what is the value of maximum resultant secondary force? Right? In the problem itself, they mentioned the V twin engine. So this problem comes under the V twin engine, and the axis at right angles. The axis between the two cylinder is right angles. That is 2 alpha. That is 2 alpha. Right? That is 90 degree. Then the connecting rods. 2 connecting rods we are using here to connect the piston to the crank. Piston to the crank. Right? But these connecting rods is connected with the single crank. Connected with the single crank. Then they given the reciprocating mass 11.5 kg and the crank radius 75 mm. So we need to convert into meter divided by 1000. Value will be 0.075 meter and length of the connecting rod 0.3 meter, and they given the speed, engine speed, that is 500 rpm, n, capital N, right? Then what we need to find? They have to find the value of maximum resultant secondary force. That is maximum resultant secondary force, Fs max, right? We need to find the value of maximum secondary force. Well, we need to find the secondary force value. First we need to find the primary force value. Then only we can able to find the value of secondary force, right? For that we need to find the angular velocity first. That formula will be 2 pi m by 60. Here we know the value of speed 500 rpm. So we can substitute the value here and find the value of omega. That is the angular velocity. The value will be 52.37 radian per second. Right? After finding the value of angular velocity, we need to find the value of resultant primary force. The formula for the resultant primary force 2m omega square r, the square root of cos square alpha cos theta the whole square plus sin square alpha plus sin square alpha sin theta the whole square. Right? In this formula, we only know the value of alpha. Only know the value of alpha, right? So we can substitute the value here and simplify the equation. Right? What's the value for cos square 45? Cos square 45 value? Cos square 45 value will be 1 by 2. So we can substitute the value here. Finally, we got the value. Primary resultant force. Primary resultant force value will be m omega square r. We know all the values, right? Then we can write the formula for the resultant secondary force. The formula will be F is equal to square root of 2 into m by n into omega square r into sin 2 theta. Right? Here also we know all the values, but we need to find the value for the maximum resultant secondary force. For the maximum resultant secondary force condition, the condition will be the sin 2 theta equal to plus or minus 1. Otherwise, we can use the theta equal to 45 or theta equal to 135. Right? This is the condition. Right? So we can apply this condition for sin theta equal to 45 degree. For theta equal to 45 degree, the theta sin 2 theta value will be 1. Sin 2 theta value will be 1. So we can substitute those values here for the maximum secondary force condition. Maximum secondary force equation. the equation will be square root of 2 into m by n into omega square r. Here we know all the values. Here we know all the values. What's by n? What's by n? It's a ratio between the length of the connecting rod to the radius, crank radius, length of the connecting rod. That is n equal to length of the connecting rod to the crank radius. Right? This is the formula for the n. Here we know all the values, so we can substitute all the values in this resultant secondary force equation and find the value of maximum resultant force, maximum resultant secondary force. The value will be 836 Newton, 836 Newton, right? In the next class I will teach you about the another most important problem in this topic. Thank you.